If you look at the schedule on the webpage, you'll see the final report is due in 1 week. And so probably that seems like it's coming up quickly. So I've got a proposal to move it back 1 week. So it'd be due on so it'd be due on Monday, April 14th instead. But as part of that, there's one condition. So let's see. So see, here's the project proposal. There's a part about feedback where I gave people feedback and they were able to get half the points back that were taken off. So in the past, only a few students have done this every year, and I think if I pushed back the deadline, I wouldn't necessarily have time to give you feedback in time for you to correct it in time for grades. So if I pushed it back a week, I would take away this 5.2 with feedback. Okay, so that's the condition. So everyone understands. So I'm going to have a vote, and only if it's kind of clearly everyone wants to push it back, I push it back. All right. So who wants to push the deadline back 1 week? And who wants to keep the deadline?
But back means you have to submit it before.
So no. So if I okay, we'll do this over again. So if you vote yes the first time, yes to push it back, then the deadline will be Monday, April 14th, but there will be no phase where you can regain points with feedback. Okay. So if you vote, so if you raise your hand the first time, it means you want to push it back. Push back the deadline to April 14th, but there will not be feedback. Because if you vote the second time, we will keep the same date, and I won't change that part of the project. Okay, so who votes to push the date back? And who votes to keep it the same? Okay, I think it's pretty strongly in favor of pushing it back. So I'm going to do that. All right, so I'll update it tonight, and I'll move it There's also homework for regression that was posted. That was posted last Thursday or Friday, I think. And so it's doing a lot of the stuff that we did in class using MATLAB. And I really tried to lay everything out, so it's pretty straightforward. I've been told you what commands to use and so forth. There's some confusion over which sort of apostrophe you should use for transpose. Try both of them if it's not working. There are some issues with what I could print in the font in MATLAB. So hopefully it's pretty straightforward what to do. But if you have questions, let's see, there was a TA session about MATLAB today. Did a lot of people show up for that?
Actually, I was not there, but tomorrow is gonna be. If anybody has any problem, I'll be available at my office hour to come and ask.
Oh, okay, so so you were not at the one today.
Yeah.
But do you know, did a lot of people show up?
I don't know. Actually, I didn't see it wrap up after that.
Okay, so if there's still, please email me if there's still some concern about MATLAB. But I'm hoping it's pretty straightforward. There wasn't too much worry about this assignment in a similar assignment in the last few years. Okay, so let's go back to the project. Just review. So I'll change the due dates. So it'll be 4 pages per student, but I want one coherent report. It should have a title and everyone's name, and should have one motivation, and then kind of list all the different things in there. So don't give me like 3 separate reports stapled together. So just to be clear on that. So, some of you may produce way more than 4 pages per student. That's fine, but part of doing research is conveying what you've done, or doing analysis, conveying what you've done in a concise way so people don't have to read lots and lots of figures, figuring out what is the most important stuff. And so, so make sure you have a title. So explore the problems and motivation. Kind of re-explain, and I want you to re-explain some stuff about your data. So this should be a standalone thing. So don't assume that I have the data collection reports or I have the intermediate reports in front of me. So you need to kind of re-describe what your data is, and if you've already described this, you can reuse, some of the text. And explain what the key idea is, right? So there should be some new idea, whether it's you want to compare different things and you want to see how they compared, you want to do some small twist on something. There should be something kind of new about it that will make me interested in reading to see what happened, right? And then kind of explain what you find, and you can use charts and like kind of different things. And also explain what you learned about this, right? So not just what was the result, but what did you learn out of the process? And so I'm hoping, I like reading these reports when I actually learn something out of it. So if you want to impress me, then show me what you found, from doing these reports. So if you have any questions about this, please, send an email or ask me after class or in office hours. The other thing I'll mention is we're planning to have the last day class is going to be a poster day where everyone is going to, or every group is going to make one poster, and you'll get a chance to present it, and it's going to be pretty crazy, lots of people with posters, and I'll have to go around and look at all the posters somehow. You're going to have to turn in a poster outline to me, which is basically a draft your poster by Wednesday, April 16th. And then if you want the school computing to print it, we'll print one that's 3 feet by 2 feet, which is maybe not as big as a normal size poster would be. It's only about this big, but we'll print it for free in a nice color printer. But that needs to be sent by the noon on the day after this. So you send me the posters by Wednesday 16th at 5 p.m. I'll look at them that night and give you feedback, and I may give extensions for a few of you if you need to make changes. So I'll talk, as we get closer, I'll talk about what I expect out of the poster in a little bit more detail. But so this will be, also it should be a lot of fun to see what everyone else has been doing. And if you're wondering, okay, why are we making posters for this class? A really important part about kind of doing data analysis, doing data mining, is explaining what you've done to someone. And so a great way to do this is to make a poster, and a lot of other people get to do it. And we have too many people to try and do presentations, and you probably all fall asleep in that. But trust me, in the poster session, you won't fall asleep. There'll be lots of kind of activity going on. And you can spend more time on things you're interested in. Maybe I'll show some examples of past posters. And there'll be a part where we'll vote. You'll vote on your favorite posters, and the posters which get the most votes will actually get, the students who made that will actually get some, will get a fair amount of bonus points. So there's some motivation to make some really cool posters. Okay, cool. So any questions on the schedule?
You mentioned earlier about that graphs assignment. That was going to be like extra or something. Did you?
So how I'm going to do it is it's going to be worth 20 points, and there'll probably be maybe 10 points of bonus. And it's optional. So if you do it, I'll average it. So the total, or maybe it's worth 10 points and there are 10 points of bonus. So I think there are 90 total points out of the homework assignments. And so if you don't do the graphs, I'll divide through by 90. If you do the graphs, I'll divide through by 100. But I think you can get 20 points on that. So, So hopefully you'll find it interesting. I think it'll also mainly be mainly be in MATLAB. So if you kind of get the grasp of doing it for this assignment, the next, hopefully it's not too much. Yeah.
Is the due date for the graphs one correct?
Yeah, so I pushed it back after the last day. So there's no exam, so I figured I can have something into exam period. If you have concerns about that, for some reason, let me know, but hopefully it's enough time to do that. So great, so today will be the last lecture on noise, and we'll be talking about privacy, and hopefully it'll be clear why this is in the noise section. And then the last part of class will all be on doing graph analysis. And this is kind of stuff like understanding social networks, we'll actually spend essentially 4 lectures building up to how PageRank works in Google, which is how they this revolutionary idea they came up with to change how now basically all of search engines work. So we'll talk about how old search engines work and how PageRank works and how it works on a large scale in MapReduce. And to do that, we'll need to talk about Markov chains, which is kind of a fundamental way to think about graphs and graph structures. And one more thing on the schedule, on a week from this coming Wednesday, so April 9th, this room I think is booked for something else. So we won't be in this room. I've booked 3105, which is in the MED building, which probably could fit everyone who's here today, but if the whole class shows up, it may be too tight. So I've given this lecture in the past, and it's online, so I'll also post a video of this lecture, so if you don't want to come, that's also okay. The other option I thought of is having that lecture outside, if the day is nice. So I'm not sure where that would be. If anyone knows of any outside classrooms on campus, we could try doing it there. Otherwise, we'll play it by ear.
Would it be possible to also include personalized PageRank in that class?
Sure, yeah. So I'll talk about personalized PageRank a little bit here. Yeah. So, so I can do that. Yeah.
Thanks.
Yeah. So that's a small add-on in the end of it. Yeah. So there are lots of variants of it after the basic idea. So I'll talk about those variants. So cool. All right. So where are we? So privacy. All right, so what is the idea of privacy in data? So, there are lots of entities now which are kind of making a business of collecting data, right? So, there's data, that's kind of available out here, and there are companies like Google or Facebook, where their business is actually collecting data about people, right? So every time you search in Google, they're recording what you searched and using that to make the search algorithms better. So if you heard this talk by Prabhakar Raghavan on Friday, he talked about how they're able to give such good search results because they are using feedback and using cross-validation in order to kind of, on other search results, to figure out which ones are effective. So they're collecting a lot of data, and Facebook has all of the personal data you posted on there. They've stored that, right? So they know that about you. So also these government agencies, so these 3-letter ones, so that are probably also collecting data about you. So they want to know, say, is there a terrorist who's going to launch some attack? They want to know that ahead of time, and in the process they may be collecting other data at the same time. So I know some people who work some of these places, so I'm not going to comment any further on that. But and then there's but they're also just researchers. So there are people like me and academics who, are interested in understanding data and want to know the properties of it. And so I can go out and do things, and some of the same data sets that these other entities are collecting, I can also collect them in certain ways. So I'm also trying to collect certain data like this. Okay, so if you think of this as data that we've been analyzing, that's great. What if one of these data points here is you, right? So what if this is you? Are you okay if these different entities are looking at all of your data online? Okay, so if this is something you post on Facebook, you're like, okay, well, this is fair game. That's fine. But what if it's something like your health records, right? So maybe then you're not so sure. So what if? So kind of to give some idea of the situation. So what if there's some hospital which is collecting some survey about which of its patients have a certain type of cancer, right? You can find various data sets online where you see a map based on the cases of cancer, and these have been collected. So let's say one hospital has been collecting this data with all of their patients. And so let's say, well, we're not going to release the patient names, but we're going to keep track of the zip code of every patient we've had, and we're going to correlate the ones, each patient will say how many in each zip code have cancer and how many don't have cancer. Okay? So maybe this is reasonable, but then what if there's like some CEO of some company who is the one, was known to have flown to some hospital for some visit, and someone looks at the data and says, oh, there's only one person in the zip code, and that's the zip code of the CEO, and he has cancer. Right? So then this has big effects on the company. The company may then have its stock prices plummet because of this issue. Right? So when certain people's medical information is released, this can be, this can have some certain consequences. So there's other things I've heard. So Facebook has tried different degrees of the focusing of the advertising it's done towards people, and so I've heard of someone who was thinking of proposing to his girlfriend, and he was shopping, for wedding rings on what's the site called, like Blue Nile or something, this online wedding ring place, and somehow his girlfriend was given an ad for this, right? So his girlfriend figured out that he was going to propose to her before he did, because Facebook had figured this out. There's another case where apparently where Target was able to figure out that some father, his daughter had been using his credit card at Target, and had figured out, based on the sort of things his daughter was buying, that she was probably pregnant, and so sent some ads to the father for some ads associated with things that you would buy if you're pregnant, very clearly. And he's like, Target, why are you sending me these ads? And then he found out his daughter was pregnant. The daughter may not have been ready to tell her father that. So you can find out certain information that you may not expect if it's been collected. So there's been some push for putting data, making data available, but to keep certain things private. And so this is hard to define what this actually means. So there's been a lot of research in trying to define what it means to have private data, and how effective these forms of privacy are. Okay, so I'm going to try and discuss this, and it'll be through various sorts of definitions and also kind of some stories and anecdotes. So kind of the goal here is there's this data, and you want to release some some database D, okay? And the goal is that database D allows some global, maybe some sort of global analysis, but does not reveal personal information. Okay. So this is kind of the general goal, but it's still kind of vague. So I'm going to try and see. So there's been various approaches to this, and I'll try and kind of specify them and then talk about some of the pros and cons of these approaches. And so the point of this is not to say, you know, necessarily there is one right way of doing this, but just to kind of make you aware of these different approaches and the trade-offs available. Like a lot of things in this class, I haven't always said there's one right solution. I said, you know, here's, you know, what's available. Dealing with data is very messy in general. So, okay, so before I get into some specific definitions, so I want to talk a little bit about the Netflix challenge. All right, so I mentioned this before, so just remind me, who's heard of the Netflix challenge before? And so who's seen any of the data? All right, so maybe a half or a third of you. So, oh wait, no, I'm not going to go into this one yet. So there's another story even earlier. Okay, so there was this story around 2000. The governor of Massachusetts, or someone in the governor's office probably, decided that it'd be great for research if they released all government employees medical records. But all these were anonymized. Okay, so someone probably at some big university, Harvard, MIT or something, said, you know, it'd be great if you could release for all the government employees their medical records, but anonymize them, so allow us to really move forward on healthcare, you know, and research in healthcare. So what they said is, we're gonna have no names. So they're going to replace names with these just some numbers of, you know, this person's ID. So there was no names, but they had other information. So they had the birthday of the person, they had the gender, and they also had the zip code. Okay, so they, and in addition, a whole bunch of their medical history. Okay, so they didn't have the names, but they said, well, we're going to tell their birthday, gender, and zip code, and we think this will be useful for the analysis of this. Okay, so this was great. Some people were doing some research on this, but then there was a grad student. Forget where, maybe it was UMass Amherst. So this was LaTanya Sweeney. So she realized for $20 you could buy the voting records of the entire state of Massachusetts in the last election. So the voting records. So with voting, there's this weird balance between making things public and private. You don't want to know how someone voted, but you may want to know who voted. This seems like a reasonable thing to do, so you can count the votes in each area and kind of cross-validate things. So when they released the voting records, they had the name of who voted, which also included their birthday, because they need to be old enough to vote. It happened to include their gender, and also include their zip code, because you needed this to determine which district they were voting in. Okay, so all the voting records in the state of Massachusetts. Okay, so this database was made public with included the health records, and she was able to get this one for $20. And then she was able to figure out that there's only one person with a certain birthday and was male in the same zip code as the governor of Massachusetts. So she figured out the health records of the governor of Massachusetts, and she printed them out, and the story is that she sent them to him in the mail. Just to kind of make a point. Right, so she actually went and mailed the governor of Massachusetts his own health records and said, I don't think this was a good idea to put this online. And so, kind of a ballsy thing to do, but she now teaches at Harvard, so, so it really made her career at least. And this was kind of one of the pivotal events in kicking off this area of the notion of privacy and anonymization. How do we study this more formally? Okay. So the large problem is you usually have two databases. You have one database that you think has been anonymized, but then there's some other database that may contain other information that you can cross these together and recover stuff that you didn't think that you could have otherwise. Okay, so this was kind of this really interesting example. So people try to come up with ways to say, well, this was not a good way of anonymizing. Just taking out someone's name and replacing it with some sort of ID. And in a lot of places, this is still what they do. They'll just replace someone's name with an ID. So I think inside of Google, they will do this. They will keep all of your records. I think they only do it for 18 months or something, but they have an anonymized ID where they take something like some transformation of your ID and then they chop off some of those of the leading bits. So there may be some collisions, but you could probably recover stuff if you really tried hard. Okay, so there were some approaches to try and formalize how you could release a database without running into this problem. So k-anonymity the idea was that, so the problem here was that inside of this zip code, there was only a single person who was male and had a certain birthday. Right? So there was only one person that had these three things as being, these three identifiers made this person unique. So k-anonymity says that so each set of each set of possible attributes must contain at least k people. So like k is like k is some parameter. Okay, so k could be like 10. So maybe that's reasonable. So what you would do, so then there were various sort of algorithms of how do you turn a database into one that's been k-anonymized. And basic approaches were, well, you start by looking at all the zip codes, and if there were at least k people, then you could think of adding in the gender. Right? And if every zip code has at least 10 k males and k females, then maybe you can add the birthday. Maybe the birthday is too specific, so you can add in, say, the month, as long as there are at least 10 people in each month. And you can kind of try and do some greedy things like this, and then there are various other approaches to try and optimize the amount of information you can release while still maintaining this property. So, but there is still a problem with this. Okay? So maybe it's not obvious now, but does anyone see what could go wrong with K, with this problem with, even if a data set has been K anonymized, let's say K is even equal to 10 or 100. So if you have some sensitive information about you that's in this database, and you know that of the sorts of things which are identifying, which are public, kind of been made public, there must be at least K-1 other people that have these same, say, zip code, gender, and birthday, who are also in the data set. How could someone still find out your private information?
Yeah, so kind of like what the Tanya Screen person did, she just took two different data sets, and you can start kind of taking intersections and narrow things down pretty quickly.
Yeah, but you can, it's the problem even with just the one data set.
You can even take your own different subsets. Like,
Yeah, so this wasn't obvious. It took a few years for people to figure this out. But what if everyone who's been anonymized with all these public attributes, they all have cancer? Right, so then you know, okay, you're one of these 10 different people, but all these people have the same trait you're trying to hide. Right, so the hidden traits could be all the same. So they may have, you know, same, the same sensitive property. So there's these K people who are identified, you know, only identify someone up to K people with these attributes, which are kind of, you could think could be in another public database. Like these voting records may only have birthday, gender, and zip code. They wouldn't have anything about your health records, right? But if everyone has the same sensitive piece of information in their health records, then you haven't really hidden anything, right? So if maybe they didn't release the birthday, but they released gender and zip code, and all the males in the governor's zip code all had cancer, then they would all, then they would still be giving that away, even though it had been, even though the data set had been K-anonymized. Okay, so this was, but this, I mean, this paper has been cited thousands of times. So this led to another approach called L diversity. So, which basically said you start with K-anonymity. So, and this paper also highlighted the way that this could break. And then said you start with this, and then you say, well, each group of K must be in their sensitive traits must be in L different groups, or there must be at least L different people with each of with each of the sensitive traits. So L. People in each K set with each sensitive trait. Right? So now you can't say that everyone in the K anonymized set has cancer. You must have at least L people with cancer and L people without cancer. So this was another kind of version of this, and so you know this kind of was a little bit safer, but this of course is going to be a harder condition to satisfy because now you have more constraints on this. But even this approach has some problems with it, and these are a little bit more subtle. But the problem is that if you could have L people in each group with each of the sensitive traits, but it may not look like the full distribution. So something like you've got a small set of people and half of them have cancer, then there's still a very high likelihood that someone in this group has cancer. So there was something called, what was this one? Called T closeness. And the idea was that within each of these K sets, so it was L, so it started with L diversity, and then it said that each K set must kind of look like the full population. So kind of, and they use what's called the Earth mover's distance, which is a certain metric between distributions. They could have used like the Kolb-Black Leibler divergence or something else, but they said, so if the general population has 5% of people having cancer, you can't have more than, say, 10% of people in any case set having cancer. Otherwise, there's too high of a likelihood you're giving too much information. So it kind of went a little bit further, and so this pushed a little bit further, but people have still broken, they found ways to break T closeness as well. There's still ways you can use one of these other data sets, or you can kind of, you can still figure out ways to get information out of here that you wouldn't want to.
So is it like breaking it definitively, or breaking it within a kind of a boundary of probability?
Well, so what will
Are you
happen
actually
is
able to identify individuals still at that point?
you can kind of identify them with a lot of certainty. So how they'll break it is people will take a data set, they'll use a construction to actually generate something that has the T closeness property for some value of T. And then they will show how they can still identify one particular instance of it. So it's kind of so there's kind of these back and forth. It's kind of like between spammers and spam detection. You try and build one level, and then people figure out kind of ways how to kind of get around this. So they just need to show one example where it breaks, and then kind of the whole foundation of it that it was supposed to preserve is no longer as secure as you thought it was. So I don't know how easy it is to do this.